there's not much in this project. Basically, I just have a well with a small 40-foot section isolated off. Because mostly what I want to do here is you have an exercise that shows you how to do the basic fluid flow that we see in let's see, basic exercise. So this one here, and this shows you how to do an invasion that then you can update the salinity and the water saturation as an invasion profile, and then you can use that to modify your resistivity calculations as a function of depth and so forth. So that's done in this basic invasion exercise. And so, well, I'll go over the things that you need for that. I wanted to go ahead and for the demo, and I'll just do also the formation test stuff. So this is the general, when you open the fluid flow simulator, this is what you have. And you have available 1D or 2D. The 1D is super fast, but it doesn't take into account any nearby layers or anything. But in many cases, if you're just doing an invasion and you're not really, a lot of times there's not a lot of interaction between layers. And so if you just want to estimate invasion into the formation, you can use the 1D and you'll get very fast results. In this case, we're going to use the 2D because we're going to be doing formation test, which uses much more small layers. And so if you were going to do invasion, you could select this, in which case you'd pick like the overbalance pressure and a depth, as well as an invasion time. We're not going to do the invasion for our example here. But then you also can select different types of mud, and you can modify those muds either with if it's oil-based mud, you can modify the composition, or else for the water-based mud, you can modify the salt concentration. And then down here, you can select formation test. And if you select invasion during tests, that will affect what's outside of the tool region. But otherwise, we'll turn that off for now. And I'll show you that you have some region here. In this case, you have to set the center depth to be somewhere in your modeling region, or it'll give you an error. So in this case, we have it set in the middle here at 1150. And we have two default tools, a dual packer, which just is azimuthally symmetric, or a default point probe. Now, these can be modeled, and I'll show you that when we do the point probe. But first, I'm just going to do a dual packer. Probably the most important thing for this, if you're doing testing, is to set up a schedule. And so you can add as many flow periods as you want. And for each flow period, you have a number of types of flow types that you can have. And then, so in this case, I usually do like a drawdown and build up for demonstration purposes. Then you can set the duration of each, the type of flow, and you can set the amount of flow. And you can also change the units if you're used to seeing different units. So here, a lot of times people prefer hours for the, maybe even hours or minutes for the durations. And for the flow, some people want, cubic centimeters per second versus barrels per day. And then up here, you can see the profile. So if you set up more, you'll see it going up and down, and so you can get various profiles. Now, so once you set up your tool, then you can go here and you can do some basic grid things. If you're just doing invasion, you might just want to use these. You can say how many radial grid blocks you want, if you want higher resolution or not. But otherwise, what we want to do is we want to make sure that we have more grids around the tool. And so we set geometrically expanding, which will expand this around the tool. Then we'll set this to 4 and set this to 4. And then one of the things that you want to look at is how many actual grids you end up with. So in this case, we have 29. If you end up with 200 grids, then you probably want to reduce that, or it's going to, even this one can take a long time to do too many grids. But 29 will work pretty fast, and you really don't need a really high resolution away from the tool. So so for this one, that's all we need because there's no real azimuthal difference. And then the next thing down here, usually I would say that you usually don't need to play with anything inside here. I've seen some advanced users that they would go in and adjust these, or they want to change what output steps they have. The only thing that here that I've seen that you might, in many practical cases, want to use is if you're doing formation testing, you sometimes may want to adjust the maximum time step because sometimes certain configurations will cause the automatic time stepping to go really slow, and then you can have, it can take too long to finish the sim. So you can set this to be something like 10 to the -5 and to make sure that the sim will finish in a reasonable amount of time. And that usually still seems to give pretty good results. Now down here, I like to use folder suffix, so it makes it easy, as you'll see, to recognize the sim that you do. And then up here, you have a bunch of links to other windows that help you to set Earth model properties. And so one of them is, for instance, the rock properties, and this automatically brings you up to things that are relevant to the fluid flow simulation, like the porosity, permeability, etc. So we've already have those set. Similarly for the fluids, PCKR is actually, I don't think we've gone over this for any of the others, but this is important. I did use it in, for setting up the NMR example previously. But what you can do is you can adjust your model parameters here. You have a variety of different capillary pressure models, and similarly with permeability models. You can see the table of data that you get, and you can have different rock classes, and then you can set the rock classes for different, you can set the rock classes for different layers here if you have multiple layers, and you can view them here and give them different colors or look at them in different ways and so forth. If you want to adjust the mud cake, you can do that in this window. And then in the advanced window, there's a lot of different settings up here regarding water properties. And the main one here is I'm going to turn off the save partial sim data because if the sim doesn't run, then I just don't want to be saving a lot of extra data. And then one thing I want to point out here is, which I mentioned during the consortium, we added this maximum radial output distance. So even though the sim will run out as far as it needs to get to do a good simulation, you really only need to save for your project, out to some reasonable amount. So here I have it set as a default to 5 meters. And then you can change your fluids if you want. Oil water contact in the example exercise that you have, it'll show you how to use this. So it creates an oil water contact point and adjusts automatically the pressure and water saturation. You can do different initializations. Usually I use the formation values. And then in this case, we can just run this. And so for the dual packer, it'll actually run really fast. Normally. Okay, don't know what happened there. Well, normally that runs really fast. So let me see. So, okay, let's assume that these ran. I have versions saved here. So for the dual packer, what we can do is you can hit this plot and we'll show the plot results. So, and you can set the times that you want to look at. So in this case, we have the So for hours, we know that we did 1 hour and half an hour. So I want to compare those. This gives us 4 plots. So then if I plot that, you can see that we have the drawdown here where it reduced the pressure, and then the buildup where it came back up. And then you can also see here at the half-hour point at the end of the drawdown where it lowered the pressure near the borehole where the tool was sucking in fluid. And then you can also see the pressure distribution here, but you can plot many other different things. So then the second thing I'll show is if you want to set up a point probe. First, we can select the default, and then you can go up here and say we want to modify this. You can adjust these parameters, and you'll see that these pictures change as you change the parameters, show you kind of what the scale looks like. And you can do the standard or a focused. Some people have recently been doing some work with the focus probes. And then you have to give it a name. So I'll just call this BGK-PP. Apply that. And now the difference is because this is an actual, the point probe is of course a completely 3D. We can use the same test schedule that we used at the other one. But for the simulation grid, this one will also have azimuthal properties. And so you can see here by default, it'll do a symmetric one, but we can adjust that. And let's make this okay, so we make something, you have a few less grids there. This one, we still have 29 vertical grids. And if you want to zoom in on this to see what it looks like, you can see how it'll look near the tool. And then this one you might set to P for point probe, and then it's possible. Well, I'm just going to try this one and see if I'm not sure if there was. It's writing input files. Okay, this one is working. Okay. However, the point probe this takes like 90 seconds to run, which is still a lot faster than it used to be. But so one thing I want to point out while that's running is that if you wanted to, you usually don't do this for testing, but for the invasion purposes, so one of the main purposes is that when you get done, that you can import. Oops, that you can import your results. I think because I'm not done with the sim, it's not letting me open that. But you can import results, and then you can, and this is what will happen in the exercise. Yeah, it'll show you how to create an inversion profile. You can look at it with the plot results, and then you can import the results. And you can import for different times. Anytime, any one of the times that is shown in the printout. You can also import to different depths. So even though we ran it to 5 meters, if you just want to import out to, the 2 meter depth of investigation or something, you can do that. So you don't have to fill in more data than you need in your Earth model. And then we can see here, like it does a different step for each of the test schedule periods. And I'm going to, maybe I'll kill this because I already have a Earth model. Well, okay, so I'm not going to wait for that to finish because we already have, as we saw, a point probe from a previous run in the Earth model. And except that one doesn't seem to be giving me my appropriate data. Maybe if I reopen it. Yeah, it's just selecting the Oh, maybe I didn't. Oh, I did change it. Okay, well, in this case, something happened with my sim. I should have let it finish. But anyway, so that would basically just show you that you can get similar images with the point probe. And we're just about running low on time here anyway. I wonder if I just try and see if I open this, reopen it. Apparently my point probe simulation got corrupted at some point. Well, I should have let that one finish. So anyway, if you have any questions on this, well, I have the 10 minutes left. You can either ask questions or I will go ahead and see if I can rerun that point probe. So does anybody have any questions? Still got a few minutes left. Might be able to look at the other exercise if you're interested in that.
We can cut it now, Bruce. It's okay.
Okay. All right. Well, that's it then. Let me turn this off.
Hey, Bruce.
Yep.
Hi. I know it's the end time, but just a quick question. Where it shows you the window, the command prompt window, and where it says under property, salt concentration, material balance error, water, different things.
This one?
What did
Or are you talking about which window?
this window, the running window where it's running the program?
This one here?
Yeah.
Okay.
So where it says things under property,
Yeah.
where it says right now material balance error.
Yeah.
Is that of significance? Like, is that telling us anything?
Not really. I think it's it always shows that basically almost. I mean, sometimes it'll have a different one, but I think that's just saying that I think internally it just tries to correct for, it's just saying, okay, it runs at that point in the iteration, it found a material balance error, and then I think there's something internally that corrects that. But I mean, it basically, for the entire time that I've ever used this thing, it always shows frequently map balance error, and I mean, it always runs fine. So,
All right. Thank you.
Yeah. Sure. Let's see if this one shows. Oh yeah, now it's showing up. Yeah, so that's what the point probe looks like. So then you can see the effect near the borehole.